I pick up where I left off. So we are on page 22 in the notes packet, example 2 down here. Again, still talking about domain. So on this one, we have two different functions, f of x equals 1 over x plus 1, and g of x equals x minus 3. So a nice reciprocal graph and a nice linear graph. What's the domain of f? Well, here's my f, okay? Domain, I have a denominator. That denominator cannot equal 0. Move the 1 over. So x cannot equal -1. Let's write that in interval notation. Right? Everything except -1. How about the range? Range, now we don't know how to graph these by hand yet, but range is everything. We could work this whole thing out to figure out the range, or you could graph it on your calculator. What we're going to find when you guys graph this, it's just shifted left 1. So my horizontal asymptote is still at 0, 0. My graph's going to look like this, right? So my break in the range is at 0. And so it would be everything except 0. Again, when I do that in interval notation, it's going to look like that. Okay, so again, you could graph this, graph it by hand, work it out if you want, solving for x and seeing what your restrictions are on y. Okay, you'll get there. All right, now let's talk about g. So g is this nice linear equation, which means my domain is all reals, and my range is all reals. So now let's do f of g of x. Well, that's f parentheses g of x. G is x minus 3, and I need to plug it in to f of x for x. So it's 1 over x minus 3 plus 1, that's minus 2. So I get 1 over x minus 2. Well, what's the domain? Domain, remember, I always look on the inside. So I look to the original domain of g, because that's on the inside, not the outside, the inside. The domain is all reals. Well, that's great. I can start with all reals. But then when I plug in all reals here, everything's all good except for what's the one that's going to make my denominator 0. So every real number will work except for 2. So my domain would be everything except 2. Okay, so you still have to look at that final answer. If there's a restriction, it's in a denominator, you still have to write that down as your answer. All right, let's go the other way. So here for this one, g of f, we do g of f of x. Well, f we know is 1 over x plus 1, and we got to plug that into g. So this would be 1 over x plus 1, that's instead of x, minus 3. Okay, well, what's my issue here? Let's look at the domain of the original. Okay, well, what was the original? The original was the inside. What's the domain? It's from everything except -1. Well, that makes sense because I still can't have a -1. So that's still a good restriction, and everything else will work. Okay, so when looking for domain, always look at the original domain and make sure it still works. Look at the original domain, make sure they still work. Again, not all reals worked. 2 didn't work, so I had to write that as my domain. Okay? All right, on to the next page. Example 5 is sort of an extra example if you'd like to work on it, especially for sort of an extra challenge, that's fine. Doing some rate of change stuff, feel free to go back and copy this on the notes. I'm going to write optional on here for now. Let's get down to example 6. This is a good one. If you want to go back again for example 5, go copy it down in the notes. Try and do it on your own. It is good practice, especially for sort of a word problem application type. All right, example 6 is kind of cool. What we're doing now is you're going to take this function h and you're going to break it down. I call this decomposition. You're going to decompose it into 2 simpler functions. So what this is I want to break it in to like an f of x and a g of x. And then I'm going to see, is it f of g of x or is it g of f of x? However I want to write that in there. Okay, which one is it going to be? So what 2 functions do we see in here? Well, we definitely see the x squared function. And you could call either one x squared, it doesn't matter. And then we also see 1 over, so I see the reciprocal function. And usually these are going to go back to those 6 basic functions that we had. Okay, that's what we're going to be combining in here. So I've got the reciprocal and I've got an x squared. Is h f of g, or is it g of f? Which one is plugged into the other one? Well, as you can see, this x squared is plugged in to this one. So g is being plugged in to f, so it would be f of g, or in other words, f of g of x. You can write it in that notation as well. Okay, so once you give me the two functions and then tell me which one it is it f of g or g of x? Now, if you had picked these in the different order, your answer down here would be g of f. Okay, so that's why there's going to be multiple answers depending on how you pick those originals. All right, let's look at b. What are the two functions that you see here? So I definitely see a cubic happening, right? And I just call it x cubed. And then my other function would be this 2x minus 5, so a linear. And then which one is inside the other one? Well, in this case, the 2x minus 5 is inside the other one. So my h of x is equal to f of g of x, again in this case, or f of g. And you can write it as either notation. You notice sometimes I do double parentheses, other times I do brackets. Either one is fine. All right, our last question here. H of x equals square root of 1 plus x to the 4th. So what do we see happening in here? I definitely see there's actually a couple things happening, right? But I see like there's this f, this 1 plus x to the 4th, and then there's also a g, which is that radical. So it would be this one inside of that one, which is g of f, right? F is being plugged into g in this case, since I wrote that in this order. Now, if you had switched them, it'd be the other way. Okay, so here, sorry, can you guys see that? Was that cut off? So now this would be f of g, right? Nope, sorry, the other way around. I just said it and then I rewrote it. It'd be g of f, right? So h of x equals g of f of x, because I'm taking that f of x, plugging it into g. Okay, so it's kind of neat, and you can write it again as this way, g of f if you want. Either notation is fine. So you're kind of working backwards to figure out what were the original two equations, or original two functions, to get then that composition. Okay? All right, you have plenty of stuff to work on. I think practice packet, there's a couple pages. There's note cards to be working on. There's a book assignment to be working on. And studying for your quiz tomorrow. This section 3.5 is not on the quiz tomorrow. Everything up through 3.4 with even and odd functions, that's all on the quiz tomorrow. Check Schoology as well. All right, see you later.